Let's take a look at the basic factoring. Indeed, this is the basic factoring review. So we should know some of the factoring already. Yes, in the previous course, we already talked about that. Let's say we want to factor ax plus 5x. Now, it's very important that we understand what the question asking us to do. The question wants us to factor out this. What's that mean? That means it wants to make it become some sort of product. A factors multiplies by another factors. Something times something. So how can I do that? I have two terms here. I have ax, I have 5x. I need to take a look at these two terms. Do they have anything in common? Do they have any common factor? X is the common factor. So we are going to factor out the x. Once we factor out the x, what would be the leftover? The leftover would be the original terms divided by x plus the original terms divided by x. Now, so indeed, you can easily verify. We can multiply the x back into the parentheses. We can distribute the x back into the parentheses. So we have x times the first fraction, and you see the x and the x cancel out, so you get back the 2x plus x times the second fraction. So this x and that x will cancel out, so you have 5x left. So indeed, factoring in this case is kind of like the reverse process of distributive property. We want to factor out the x, and the leftover would be the original terms divided by the x. So that would give me x times parenthesis a plus 5. Take a look at the next one. How many terms do I have? How many terms do we have? We have two. Terms are separated by plus or minus. In these two terms, x cubed and 7x squared, what do they have in common? X squared. So I'm going to factor out the x squared. And then times the leftover, which is x cubed divided by x squared plus 7x squared divided by x squared. Simplify that, so that becomes x squared times, open parenthesis, x cubed divided by x squared. What would that be? X plus 7x squared divided by x squared. What do we have? 7. How about this one? Again, I have two terms. What do they have in common? Let's try to figure that out. The number first. 6 and 9. What do they have in common? 3. And now the variable. X cubed and x. What do they have in common? X. How about y then? Y squared and y. What do they have in common? Y. So the GCF is 3xy. So I'm going to factor out the 3xy. So what do I have left? 6x cubed y squared divided by 3xy plus 9xy divided by 3xy. The leftover will always be the original terms divided by the GCF. So now I got the 3xy multiply. Take a look at the first one. Let's do it step by step. 3 go into 6 2 times. X cubed divided by x. What do I get? it would be x squared. Y squared divided by y, what would that be? Y plus 9 divided by 3. I have 3. X divided by x, what would that be? Would that be x squared? X divided by x is what? Is 1. And y divided by y is what? 1. So do I write down 3, 1, 1? No, I'm not getting information. So I can get rid of the 1. How come I can get rid of the 1? Because it's 3 times 1 times 1. So indeed, we don't have to write down that particular 1. So we can just simply say plus 3. That would be sufficient enough. Now be careful. Terminology is definitely important. Sometimes when we see x divided by x, some student will say, oh, they cancel out. Yes, many people say that. But you have to understand, cancel out is actually an ambiguous terminology. Sometimes we have x minus x. We also say they cancel out. In that case, when you have x minus x, what do you get? You have 0. So when you say, oh, they cancel out, sometimes it will lead to another confusion. Especially in this case, even though we know x divided by x is 1, we don't need to write down the 1 because we have another factors over there. So sometimes student got a little bit confused. Oh, x divided by x is 0 because they cancel out. That's very common mistake. So be very careful about that. Try to use the proper terminology, always help. X divided by x, indeed, they reduce. Now, another thing is, when we factor out the 3xy or factor out the x squared, I always like to say factor out the x squared. Try not to use other terminology like pull out the x squared or take out the x squared. Although many people say that, and you should understand what they are talking about. We love take out, but if you keep saying that take out, take out, take out, sometime it will lead to another confusion. Because take out could also means what? Subtraction. So some people keep saying that and say, oh, you know, I have a 7x squared. I pull out the x squared. So what do I have left? I have 6x squared left. I know that I'm cool. 7x squared minus x squared is 6x squared. Or for this one, 9xy, I take out 3xy. That means, oh, 9 of them, I take out 3, so I got 6xy left. And that is a common careless mistake. So be very careful. We always factor out the GCF. And the leftover will be the original term divided by the GCF. See another one? How many terms do I have? 3. Wow. So we have to do it step by step. Take a look at the number first. 15, 9, and 12. What do they have in common? 3. Very good. How about the variable x? X cubed, x to the 4th, x squared. What do they have in common? X squared. How about the variable y? Y to the 6th, y to the 4th, y to the 5th. Y to the 4th. We are looking for the smaller exponent. So now that is the GCF. What would be the leftover? Original terms divided by the GCF. Original terms divided by the GCF. Original terms divided by the GCF. So write it out clearly and then take a look at what happened to the leftover. We got 3x squared y to the 4 times, open parenthesis. Take a look at the first fraction. What would be the leftover? 3 go into 15. How many times? 5 times. X cubed divided by x squared. Y to the 6th divided by y to the 4th. Y squared. Minus 9 divided by 3. 3. X to the 4th divided by x squared. X squared. Y to the 4th divided by y to the 4th. What would that be? Y to the 4th divided by y to the 4th. What do we get? 1. Do I need to put down that 1? No, because I have some other factor. And then plus what? 12 divided by 3. 4. X squared divided by x squared. 1. Do I need to put down that 1? No. Y to the 5th divided by y to the 4th. That is y. So that would be the leftover. Now I know some of you will ask that question. Do I have to write the middle step? Because we are lazy. We don't want to write out everything. Now, indeed, as times move on, you should be able to handle the problem and jump to the answer like this. But at the same time, somewhere in your notes, especially at the beginning stage, you should help yourself to write it out clearly. How do I get to the final answer like that? Because I know the leftover would be the original terms divided by the GCF. Original terms divided by the GCF. You need to have that in your notes. Wait until you master all this really well. Then you will feel comfortable to jump to the answer. Indeed, as we move on, we will engage some more complicated situation. And then at that time, you should be able to jump a little bit faster. You probably don't want to write out every single step. Otherwise, it will become very lengthy. But at this point, don't let yourself to be lazy and feel like that, oh, I'm cool. I can jump all the way to the answer. Because if you don't get a good foundation here, in the future, you will have serious trouble. Sometimes students just simply jump to the answer like that, and then they turn out they got something wrong in between. You force people to give you nothing, no credit, because don't even know how you get to that point. There could be a lot of different possibility. Is that because you have trouble doing the division or you have trouble in the factoring? Now, so at the beginning stage, please tell yourself, let me slow down myself a little bit. Let me write it out clearly so that I can have something in my notes for reference. A month later, I go back to take a look. I would fully understand how do I get to this particular point. Because I factor out the GCF, the leftover would be the original term divided by the GCF. Let's take a look at another one. How many terms do we have this time? 2. Looks relatively simple. What is the GCF? 3x. I factor out the GCF, so it would become 3x times the original terms divided by the GCF plus the original terms divided by the GCF. So that would give me 3x times, what is the leftover? 6x squared divided by 3x, 2x. Do I need to plus something? 3x divided by 3x, what would that be? It's 1. Do I need to put down that 1? But how come before that we don't put down 1? But before that, so that means if this is x divided by x, then we don't need to put down 1? Now be very careful. When we have 3x divided by 3x, we should have 1. Before that, we also have some other example. X divided by x, yes, is 1. Y divided by y is also 1. So we have 3 times 1 times 1. In that case, is it necessary for me to write down the 1? There's no need to, although I could, but I know 1 times anything is equal to anything itself. So that is the reason why we can just simply skip the 1 as you read the 1 cancel out. But be very careful. Don't get yourself wrong and feel like that, oh, you know, x divided by x is nothing because, hey, you know, before that, we can cancel out. We don't put down the 1 at all. When 1 is the only factor left, we must put down the 1. How about another one? We have to factor negative 4x plus 12. 4 and 12, what would be the common factor? Would that be 3? It would be 4. Now, that's true. We can factor out the 4. But this time, we are going to factor not just 4, but negative 4. Because we like whatever inside the parenthesis will begins with a positive term. So let's see what happens. If I factor out the negative 4 times, the leftover would be negative 4x divided by negative 4 plus 12 divided by negative 4. So that would give you negative 4 times, open parenthesis, negative divided by negative, positive. 4x divided by 4x. 12 divided by negative 4, negative 3. Plus a negative 3, that means minus 3. So turn out we got negative x, negative 4 times, open parenthesis, x minus 3. Let's see another one. What do they have in common? 5, but since it begins with negative, so we love to factor out the negative also, so that whatever inside the parenthesis will begins with positive. So we have a negative 5 factor out, and the leftover would be negative 5y squared divided by negative 5 plus 40x divided by negative 5. So we got negative 5 times, open parenthesis, y squared minus 8x, like this. So far so good, right? Now in these two examples, indeed, if we want to have the positive terms to begin with inside the parentheses, there could be another alternative. Some student would say that, hey, why not I just flip these two around? So to make the positive term go first. And if that is the case, then we can factor out just simply 4 or just simply 5. That is quite true if you consider that way. But we should feel very comfortable to factor out a negative number because sometimes we have no choice. Just like this one, both terms will have the negative in front. So there's no way that even though we flip them around, we will have to deal with the situation negative. What do they have in common? Negative 4x. So let's factor out the negative 4x. So what is the leftover? It would be negative ax squared over the negative 4x minus 12x divided by negative 4x. So that would becomes negative 4x times the leftover would be 2x minus a negative, that means it's a plus 12x divided by 4x 3. All right, let's try out this.